yesterday you've seen a lot about the basics of how to create a demo, with a few things that were left blank or in which we didn't go into details. So, just a few polls so far. Have you managed to create a simple demo that works? Does someone have any specific issues in mind, or not yet? Yeah?
Okay, we add text such as a presentation, quick presentation of the subject at the beginning.
Add text to explain what the demo is about? Yes. So it's not on the slide, but I will modify the slide to show the command. It's just, again, in the DDL, you just have a field description in which you can write a description of what the method is about. So I will add it to the slide this afternoon and talk a bit more about it tomorrow, because we will actually ask you a few specific things to write in this description, such as the parameters. But I will edit the slide this afternoon as well, so you can add some things now if you want. Yeah?
Can we display the progress while the execution is running? Because sometimes it takes a long time, so I want to show, I want to print basically what's happening inside. Is that possible?
No, that's not possible. You can change your code to print timestamps of when it's happening, but you will only have the result at the end. So it can be good for debugging if you want to know which specific step is taking a lot of time, but you cannot see it live. Also not if it's taking a lot of time. So there's a time to run the demo, but also if you have recently modified the demo or the repository, the first time you load the demo afterwards, it will have to reconstruct the demo, so the Docker file, download the images, etc., before running it. So after you modify your demo, the first try can be a bit slow, even take a few minutes, depending on the Docker file, because it will need to reconstruct everything. But after that, the Docker is saved, so it is faster.
Also, if I want to show some intermediate results, do I have to wait until end to show everything, or?
Yes. So far, there is no interactive component in IPOL, so you have to show all the results at the same time. But you can save them before, of course, and show them afterwards. But yeah, you will have to wait until everything is done to show all the intermediate results.
For 3D results, such as we pipeplot when we have a 3D object, and then if we want just to say here and to have it plotting if there is a bug.
So you construct a 3D model and you want to show it in a way that the user can use it interactively, right?
Not interactively, because but at least have an image, because with pipeplot it's interactive, and when I save it with pipeplot as an image, the object is not here anymore.
Then it's probably something to work on the pipeplot side, possibly because it's not interactive. You may need to specify a few specific libraries for pipeplot instead of the interactive ones, depending on your version. And possibly you have to specify the view in advance. So we can look at that together in the afternoon if you want.
And the WebGL demos are possible, which are interactive?
Sorry?
WebGL, which is like you can push it in the web browser.
So you want interactive 3D models. So this is a bit harder, but definitely possible. I will show how to output HTML files. So I show it with Plotly and with Bokeh. I don't think these two libraries have 3D capabilities, But there are many libraries to output, to create 3D representations, and at least one of them should enable you to output your 3D model as an HTML visualizer. So in which case you can input it, well, you can set it as an output in IPOL and display it.
There is one demo doing that, but I don't remember which one.
Okay.
But it was set up by Gabriele, and I'll find it out.
Okay, thank you. Then I will look for the demo and add it as an example in the slides, so you have the example as well. Any other question? If not, so I will move with a new tutorial on more details. And of course, you can ask questions later, tomorrow, or at any time this afternoon. So in this tutorial, a few things are important for everyone, such as how to populate the archive. Other things are useful for some of you, won't be useful for others. So for instance, I will show how to output HTML files. It's something you can want to do. For some demos, it won't be useful. So there are more examples in the slides than I will discuss here. Of course, you can ask questions and you can have the slides as well. But don't worry, you don't have to learn everything. Yesterday, it was the basics that all demos require. Now it's more, well, not just, there are things that all of you will need, such as the archive, but also a few things that will be more specific depending on your demo. Here I want to show you most of the possibilities in IPOL. So there are things you may need, there are things that are nice to have, you won't always need it. So this is a demo creation process. We've been through it yesterday. So the first 4 lines here, we've done most of it. So at least the first 3 lines, we've done it. The 4th line, I show it to you today. And for the last 2 lines, you've seen the basics, and now we see the details. So first of all, a word about using large files on IPOL. So all the code, as you know, must be on GitHub. But you cannot put files larger than 100 megabytes. So if you have large files, larger than 100 megabytes, you need to upload them somewhere else. So the easiest way to do it, if you can, on your own server with public HTML access, then you can just provide the URL to load it, and it's very easy. If you don't have your own server with public HTML access, we can also provide you with a link. So I will send you the link by email. It's a link that you should not share to the external world because it basically allows anyone writing access to the repository. So keep it internally in the workshop. Don't share it to everyone. Thank you. So now I suppose you have a URL for your large file. So either on your own server or on the link we will provide. If you want, you can put it in a specific folder on your repository. So for instance, if you don't want it at the root of your code, but in a checkpoint folder, you can put it in the Docker file. So you have the command run make directory $bin checkpoint, where $bin is where the code will be. And then you can use wget to download it at this location. So here it's in the checkpoints folder in the $bin directory. If you want to put it at the root of the directory, you don't need to create a directory here, and you don't need the checkpoints here, just $bin/largefile.pth or any other format. So if you follow these lines, your file will be in $bin/checkpoints/largefile.pth where your code is basically in $bin. So it's those 4 lines you should put in the Docker file. Well, actually those lines, there are 3 because we download 3 models. If you only download 1 file, you just need one make directory command and one to download it. So here is a full Docker file. The important thing here is that you put these lines after having created the $bin directory. So after the end bin, run make dir bin, work dir bin, and copy. So you want to put it in the $bin directory. So you only do it after it is created. More generally, in Docker files, if you have other commands to run, you can use most existing commands in a Debian or Linux system by using when in capital letters, then your own command. And there are as well a few different commands for setting environment variables or a working directory or doing some copy pasting. But most probably you won't need that outside of what we already put in the Docker file. So if your weights are on this path, then you also need to be careful when loading the weights in the code. Because if you, for instance, if your weights are in a checkpoint/weights, but your code is main.py in your repository, if you run it locally, you might be tempted to use, for instance, if you run it with PyTorch, to load the file at the path checkpoint/weights.pth. Here it will not work, because the only case where this would work is if you don't put the $bin. Well, if you don't do this, because you don't have access to $bin, so it's not. Okay. So instead of using this as you would do locally, you don't. Because if you do, it will only work if you are in the $bin directory where your code is already. So this is the case when you run it locally, because most often you run it from the same folder. On IPOL, it will not be run from the same folder. So one way to run it is to use this line, the first line here, root equal to something, to know what path, in which path the code file is. Then you write the path to the weights relative to the code file. And then this works if your code is in $bin. If your code is in another subfolder, you have to go back one folder here, the 2 dots and slash, before loading into the checkpoints directory. So this is all for using large files. If you follow these lines, you should be able to download files from the Docker file and read them in your code. And returning to your question earlier about the time it takes, note that as soon as you do this, every time you change your demo or the code, the Docker file will be reconstructed on the first run of the demo, which means that it will have to download the file again. So if it is a very large file, as soon as you do it, expect that the first run of your demo after any modification will take slightly longer because it will have to download the file. So this is to use large files. Now, I've talked a lot about Python code, but not all demos are in Python. Some of you may be using compiled languages such as C, C++, or anything else. And even if you don't, you might be using a project in which you have a dependency you need to compile. So for instance, you have a very specific project which has a dependency you cannot install with pip or in Debian. You need to download the code. So like we taught you, you can use it for large files. You can also use it to download the external code. although you can also put it in your repository if you prefer. But then you have to compile it in any case. So it's very similar to downloading large files. You do it in the Docker file. So supposing your makefile is in $bin/makefile.gcc, you just have to use the command run make-f makefile.gcc. So what's important here is the run. After that, the make-f makefile.gcc, it's really depending on your own code and what you want to compile. Here, it's if you have a makefile.gcc. If you want to use CMake, if you have another formatting for compiling, you will have to change what is after the run. So this is assuming your makefile is directly in $bin. In many cases, especially if it's a dependency, the makefile will not be in $bin. It will be in another subfolder. So before compiling it, you have to change your working directory. So you use the workdir docker command to go to this directory. Then you run the make command as if you were in the directory. And then, this is important, don't forget to go back to the $bin directory for the demo to run correctly. So this part, the changing workdir, is important if you want to change directories. Don't forget to go back to $bin afterwards. The run command, what is inside, so the make, etc., will depend a lot on your code. And as with downloading large files, only do it after the $bin directory has been created. So like in this example, it needs to be after line 16, not before line 12. And as before, don't change what is after line 23 unless you have a very good reason. So, especially to compile code, you will need a lot of packages. So compilation packages, standard libraries for C, C++ projects. A lot of them are already installed, so you can check this link to see what is already installed. Just to show you, here you have the list of demos. You can, for the V2 packet images which we recommend, you can load the list here. So here you have a lot of libraries already installed. If you're using a V1 demo, it's just more below. So here. And if you need something else, so you can go back to yesterday's slides and simply add the Debian packages you need to add in .ipol/packages.txt. So probably this is all you will need to change in the Docker file. So from now on, what we will do will be to show you how to add blobs in the image, in the demo, and then to change the DDL to have more different options. So now I will explain you how to add blobs. So when I talk about blobs, it's not like this kind of blobs. Blobs are actually a name to refer to example data. So this is your demo now, at least the template demo. Users have to upload their data. This is a bit tedious. It's of course necessary to have it because users may want to upload their data to test the code on their own inputs. But in many cases, users don't want to use their inputs. They just want to look how the demo runs, what does the method do, but they don't care on which data it is used. So for these users, you can provide some example data. That way, so here there's only one, they can click on the example, use it as if they uploaded it themselves, and see results on it, without having to upload a sample by themselves. So this is very useful, not for someone who really wants to understand what is done on their own input, but for someone who just wants to know what the method does, or simply to reproduce experiments you did in your article. In your article, you will show results on several specific inputs. You can upload them here as well, so the user can try them directly. So how to do it? Go back to the control panel, where you can edit your DDL and the demo. And here, click on blobs. So when you click on blobs, you will see a new screen. For now, you will add blobs by hand, so click Add New Blob. Then you can either drag and drop or pick a file with a browser. So you just use a browser to choose, for instance, an image you want to use. So here you will have 4 fields. The first field is to fill the title. So here the title is R1, etc. So pick something that the user can read, not like in what I showed just a few seconds ago. Set and position set, you do not need it right now. It is for a specific use case I will show later. And credits, it is if you want to add credits to the image. So for instance, if you took it from the internet, write the credits here to explain where you took it from. And of course, we take it if the copyright allows it, and show the copyright license here. So then, once you're done, you just click Upload. And if you go back to so you can also add several blobs at a time. So, like here. So, as you will see, the title is automatically replaced with a file name. In most cases, you will want to rewrite it to something more legible unless your file name is already good. And when you go back to the demo, you will see the example, and now people can just click on it and use it as their own data. So this is very good for images and videos because the user can click on it. But let's suppose you do a demo that requires the user to upload some text. You cannot view text, so you will just see this, and the user will see this. This is not very practical. In most cases, then, I recommend adding a visual representation of your image, of your input. So, for instance, it can be the few words of the text, or an image containing text if you want to say something. If your input is a signal, you can put a graph representation of the signal, so an image. If your input is a 3D model, you can put a photo of the model, so one rendering of it. If your input is a table, you can show a few lines of it, or an image of text describing what it is. So here you can do whatever you want. You do not need to do right now while you are debugging, but you will want to do it at some point before publishing. So the visual representation, you drop it at the bottom. So it only works by drag and drop. So you take your file browser and you drag and drop it here. And then once you're done, you click on Upload. And then your text will not be like this, but like this, which is more legible if you have a good visual representation for your data. So now, this, up to now, has been for demos where there is one input. So for instance, the user uploads, yeah?
If the input is video, can the user click on it and it will play?
Sorry?
If the input is a video,
yes,
can user play it?
Yes. So if your input is a video, it is like an image, a user can see it, play it. I'm not sure it works right now, but at least see an image. Oh, perfect, it works. So you can see the video.
Some parameters, basic parameters associated to the input. For example, the parameters we enter in Sigma or something like that. If we click in the blob, it will set the basic parameters we want to see with the example.
Okay, Okay, so what you want is for the here, for instance, for a sigma parameter, to change automatically depending on the image. So this is not possible. This is actually by design. We want the default parameters you select to be globally decent for all possible inputs. It could, well, not always, but it could be used maliciously to be able to change the default parameters for each input, because then you could, for instance, optimize the parameters for each image, but then you would not show how the demo would work normally, because you could have hand-tuned the parameters. But in the comments and as well in the description, you can say, for instance, if this is a specific case, you can say this will work better on this image with these parameters, or in the parameters you can say, for instance, if the image is dark, you can use a larger value of sigma. If the image is very light, you can use a smaller value, or similar things. So you can indicate to the user how the demo would work better with other parameters, but you cannot change it for them. So up to now, you've been using one input in the demo. So for instance, one image, you get the results. But in some cases, you might need several inputs at the same time. So for instance, if you are doing work on registration, the user should upload 2 images, and the algorithm will find some links between the 2 images and try to match them together. For this demo, you need 2 inputs at the same time. To do this, you will use here the set and position in set. So for instance, if you have 2 inputs per one of the demo, you should have 2 inputs in the same set. So here the set name is a bit gray. And then you write the position in set. So the image at position 0 will be named $input_0 in IPOL, and the image at position 1 will be named $input_1. So here you have 3 sets of 2 inputs each. So a bit gray, those 2 images, which can be matched together. Flower and box, these are these 2 images, which can again be used together. And finally, draw and train. So usually the 2 images will be linked in this case. And when you are on the demo, the user will select one set of images. So the first one will be $input_0, the second one will be $input_1. So this will only allow you to select two specific images from a set. So you don't select each image separately. If you need 2 inputs, then you have to select a set with 2 inputs. In some cases, it can make sense to let the user select 2 inputs as he wants from a group of images. So for instance, you might want to select the bird image here and the box together. So for now, this is not possible. You can only provide sets with pairs of images. So until now, you've added blobs by hand. So you create a demo, you add your own blobs, so your own examples, and you're done. But you can also use existing templates. So here, instead, when you are on the blob description here, so when you click on blobs, instead of blobs, you can choose add template. You have a lot of existing templates, which are templates made by other users, which already contain some inputs. So if you find a template that is good for your use, you can choose it. For instance, here we choose the template portrait. And if I do it, I have a lot of example images already loaded into the demo. So if you click on templates, at the top of almost any page in the control panel, you will see a list of existing templates. So you can browse them and you can make your own template as well if you want. A big warning here, it is in theory possible to edit our templates. Please do not do it. Don't edit existing templates without the creator's permission. Do not delete any existing template, because if you edit an existing template, it will not just change it for your own demo. It will change it for everyone using it, so for every demo using it. So if you have a template and you want to add more images, you can actually, I will show it later, you can actually combine templates and blobs. So use a template or more and add your own images on your demo only on top of it. But do not edit the existing templates. But you can create a new template if you want. You just have to click here on Create Template. You add a name. It's very important in the name to not use any spaces. So normally it should not do any harm, just reject the template name. But before, it used to break the system, so don't take any risks. So you add a template name with no spaces, and you arrive in this page where you can add new blobs. So here, when you add new blobs, it works as if you did it by hand. So as earlier, when you added blobs specifically for your demo. Except that now, it will be in the template. So you can select it and have it, for instance, if you have several demos, or if you want someone else to make another demo and be able to use the same template. So how to choose between blobs for your specific demo or blob templates? If your inputs are very specific to your demo, and probably they will not be useful for other demos, then it's much easier to use blobs directly. So for instance, if you have a very specific use case on a domain where you know no other people will work, or no other demos will be made, if your demo has very specific requirements, for instance, if you need a very specific number of inputs, and it's very unlikely other demos will need this very specific combination, or if it's just a group of images for test examples. For instance, in your article, you worked on several images or several inputs. Naturally, you want to add them to your demo so that the user can reproduce your experiments. But there are only your experiments for your articles. These inputs might not be useful for other demos. So in all of those cases, you can just use them as blobs, use it for your own demo. But in some cases, you have examples that can be useful for other people. So for instance, if you build a data set of, if you build a list of blobs of generated images, generated faces, for instance, it can be used for a lot of applications, for forensics, for relighting, even for simple image processing. So in that case, it makes a lot of sense to create a new template. And finally, as I explained, you can mix both templates and blobs. So use a template for a base image, either your own or one that already exists, and then add your own blobs for specific cases to your demo. And you can also mix several templates. So in the template selection, you just select several, and you will have inputs from all the templates. So a bit of troubleshooting here. If you edit a blob, sometimes it might not work well. In that case, delete it and recreate the blob. And also, you cannot control the order in which the blobs are shown. So it's not exactly random, but you cannot control it. So do not try, for instance, here, do not try to make it so that this image appears first, this one appears second, etc. You will spend a lot of time and it will not work as you intend. So this is it for adding blobs. Now, the main part of today is about the DDL. So you've seen a lot of it yesterday, but not all of the options. So now I will delve into more details to show you almost all the options you can add. Not all of them because there are even more, but a pretty complete list of possibilities still. So here, as a reminder of yesterday, this is a list of things that are done in the DDL. For reference, if you read the slides later. You have the general part, which describes the title of the demo, for instance. Build, which explains how to locate the Docker file and compile it, run it. Input, which describes the input part, the inputs uploaded by the users or by you as examples and how they are to be processed. Params, which shows the parameters the user can change. So Sigma in the template demo. Run, which is the line to run in your demo. So the line you have in command line locally, but with the parameter name and $bin, etc. Wizards, which lists the wizards that are shown to the user afterwards. And archive. You have not seen it yesterday, but it can be used to show an history of what was done by previous users. So first of all, general and build. So general, you can add the demo title. So here, don't forget to change it also in the edit demo part, because it will change at different places. So you need to update both if you want to change your title. Requirements, until now, it's only been Docker. For the specific case where you need to use a GPU, you need to use Docker, GPU, not just Docker. So that IPOL will know that it needs to select a GPU server to run your demo. Otherwise, it will select the base server, and we have an error saying that there is no CUDA and no GPU available in your system. So in the general part, this is also where you can add a description, which will be shown on top of the demo. So I will edit the slide to add it as well. Notice, by the way, I've seen some errors yesterday. Here you write a comma at the end of a line, but not on the last line. So this is not Python. If this is the last line before you close the brackets, you can't use a comma. So it is a bit more rigid than what you can do in Python, and the DDL will not compile if you forget, if you add a comma to one too many comma. A note on that, yeah?
Do you have to modify the
So if you use a GPU, so where is the Docker file? Okay, here. If you need a GPU, this line, the first line, you will need to change it because you will need to use a GPU image. So you can look at, on yesterday's slides, there is a list of images and you can just add a dash GPU. It only works on Python 3.11, as well for limited option on 3.10. For the rest of the Docker file, you might not need to modify it unless you have some specific use cases. So in very specific cases, you might need even a custom Docker image. In that case, we can help you to it because it's really not trivial to use it. And if you use a GPU, you are probably using a model as well. If you have large files, large weights, we need to download them. So for this, you have the beginning of my slides to also modify the Docker file to download the weights and use them. Okay, so here. So now for the build part. The URL is the URL of the GitHub repository, so there was no text yesterday, now you have it. And especially for the URL, you can actually get it very simply. If you go to your repository, you click on code, specifically the SSH part, and it is this. So there's even a very handy button on GitHub to copy it, and you can just paste it on the DDL. The revision, in most cases, if you create a new repository on GitHub, it will be origin/main. But if you have another repository, or on other, if you clone it from other sources on GitHub, sometimes it will not be origin/main, but origin/master, which in GitHub was used a few years ago. It's no longer used, but it remains for other repositories. And of course, this is if you want to use the main branch. If you have several branches in your project, you can also specify one specific branch you want to use. And finally, the Docker file. So here, this is the Docker file location in your repository. If you use a template, it is in .ipol/dockerfile. We recommend keeping that location. It makes things more uniform and easy to handle. But if you have a reason to use something else, don't forget to change it in the DDL, not just in the repository, because the demo system needs to be able to look at the specific Docker file. It will not find it by magic. So now for the input section. So as I told you yesterday, inputs are located in the exec working directory, not in $bin. So inputs are in exec, which is also where the execution will take place. So when you refer to inputs, you don't need to look for very complicated names. You can just send them to the demo in one with $input_0 for the first input. If you have several inputs, the next ones are named sequentially, so input 1, etc. Now for the types of inputs, we have 3 supported types: images, videos, and data. So the most complete and simple one to use is image, because in images, IPOL will manage most of it for you. So here are a few examples of what you can do. On the right, by the way, is how you do it if you have several inputs. So you have a list with 2 inputs rather than a list with just 1. So the description is what will be shown to the user. So it will be told, here you need to input, for instance, this time series to analyze. If you write it as on top, it will just be shown input, which can be nice if the input is obvious to the user, but a lot of times it's good to have more explanation. The type for image is the format, not the PNG or JPEG format, but the encoding of the image, how many channels it will have, and how much precision it will have. So basically, if you load it, for instance, as an array, how many dimensions will it have, how many bits will each number have. So for the number of channels, you have several options. You can have 3x, which means you will have 3 channels, so a color image. 1x will be 1 channel, so a grayscale image. And just x means you don't touch the number of channels, and you pass it to the demo without converting it. So if you specify 3x, it means that the demo will convert the image to a 3-color image. So if it is provided as grayscale, it will duplicate the gray channel, make it in three copies to have a 3-channel image. On the other hand, if you ask for a 1-channel image and the user provides a color image, it will convert it with ImageMagick to grayscale. You can also ask for more specific dimensions. So you can ask for 4x for HBA with an alpha transparency channel. In that case, it will not convert it So if the user provides an image with an alpha channel, it will be okay. If it's not an image with an alpha channel, the system will throw an error and we ask the user to provide an image with an alpha channel. So if you want to process any image and add the alpha channel yourself if there's none, then just specify X, not 4X, and manage the input yourself. You can also ask for a different number of channels. So this is especially relevant if you work on satellite images, where you can normally ask for an arbitrary number of channels. So either X, and you read the image yourself to see how many channels it has, or a specific number, and the system throws an error if it's not this number, which is useful, for instance, if you know you want images with 5 channels. If there's more or less channels, you know it's not a correct image, and you cannot run your demo. Then let the system run the error. So a note here, if you use the X, so for any number of channels, it means you have to manage the number of channels yourself. So the input might have 1 channel, it might have 3 channels, it might have 4 channels with transparency. If it's a TIFF file, it could have even more channels. So you have to manage the number of dimensions to know how many and process your image accordingly. So now for the extension, so ext here, you can say .png, it will convert the image to PNG if it's not already. You can ask for JPEG or TIFF images. If you don't have a specific reason for doing it, we recommend staying with PNG images. The max pixels here is the max size of the image in number of pixels. So not here, it's a number of pixels, not a width or an height. So if you want the size limit to be a 4000 by 4000 image, you specify 4000 by 4000. So here you can do simple calculus and use the asterisk for simple multiplications so that it remains legible in the DDL. But don't put just 4000, otherwise it will limit the image to 4000 pixels, which is not even a 100 by 100 image, which is very small. So when choosing the max number of pixels, keep in mind that the demo must run smoothly in 30 to 60 seconds, unless you have a very good reason for needing larger images. Keep the inputs small enough that your demos run fast enough. Finally, for images, there is a forbid preprocess option. By default, it is false, but you can set it to true, in which case, if the image is not already in the requirements, an error will be thrown. So, by default, it is false. So, if the image is too large, it will be downsized. If the image does not have the correct number of channels, it will be converted, at least if you requested 1 or 3 channels. If the image does not have the correct extension, it will be converted. If you set forbid preprocess to true, it will not show, well, it will not resize the image. If it is too large, it will throw an error. It will not change the number of channels. If the number is not right, it will throw an error and stop the demo. This is useful if you work on image processing demos, where sometimes you want to work on very fine-grained details, which are lost if the image needs to be resized. In that case, it's easier to say forbid preprocess to set it to true. And if the input is too large, the demo will throw an error saying to the user that he needs to reduce its size by himself, for instance, by cropping the image or providing another one entirely. So, about the D-type, so I explained the 3x, 1x, or x. After that, you have 8i, which means you use 8-bit precision integers, which are the default. which should be used for almost all of you. In very specific cases, you might want 16 bits precision. So keep in mind it will result in larger files. And they are supported, but your code might handle it differently. So if you use Python, for instance, most image reading libraries like IMAGE.io, scikit-image, etc., most of them will only handle 8 bits, and if you provide them with a 16-bit image, it will just convert it and reduce it to 8 bits. So in that case, it's not really helpful. But you have the option if you have a specific bit. So check the template here if you want. There are a lot of options in images. Actually, I can show it now. So there are a lot of options with commands to describe it. Okay, I have to fix the demo. Normally there are a few examples to show how it works. It looks like the demo was edited recently. Well, I will put them back so that you can check the demo as well with examples. Back to the slides. So this is for image inputs. Now you may need to use video inputs. So you can write it here. So the input can be a video. You specify type as video. The maximum weight, I think in bytes. Yeah, it seems to be in bytes. The maximum resolution of the video. The maximum number of frames in the video. So for instance, 100 frames, 1000 frames. You also have the option as frames. If you do it, then instead of giving the video to your demo, it will just give a list of frames to the demo. And you can specify an extension, for instance, .mp4. I recommend you not to do it because the video in that case will not be converted to MP4, it will be renamed, and it's not very useful for you. So it also means, unfortunately, at least for now in videos, if you load a video, your code needs to manage different types of videos. So you don't know in advance what kind of format the user will upload. So use a library to load the videos that can with as many different possibilities as possible. Yeah?
What is number of frames in the video that user uploads is more than the max frame, then what will happen?
So I am not sure here. I need to check, but probably either the demo will be rejected, so there will be an error, please reduce the number of frames, or it will be either resized or cropped to the specified number of frames. So I need to check for this. So yeah, so I suggest not using the extension and manage with a library, if you can, the type of video encoding in your code. Another option, temporary.
For example, an MOV video doesn't work.
Sorry?
If the user uploads an MOV video.
A demo?
MOV video.
Yeah.
I think it will work. Because the system is fully in place.
Yes, so actually, if you don't specify extension .mp4, so you don't use extension at all, which is what we recommend, the demo will still be a .mov. But in your code, you need to understand what format the video is in and run it yourself. So, of course, you cannot support all existing formats, there are just too many. So I will show you, not today but tomorrow, how to send yourself an error to the demo system if the user provides something that is not correct for you. That way the demo system will still provide an error message, not just some random error that you may have seen while debugging, but something legible saying whatever you want. So you can write, for instance, only AV or MP4 or H.265 image videos are supported. So the users know what it can upload and how it can process its own videos. So there is another option for videos, which is used in a few demos. It can be helpful if you don't want IPOL to manage your videos at all. So you don't want it to reduce frames, check for it, etc. You can use the data type, which I will show later. Data type can be anything, so you can use it for videos. Not in that case, it means you will not be able to see, well, the users will not be able to see its video when you upload it. And the same goes in your blogs, you will have to upload yourself the visual representations. You can also ask the user to upload frames as a zip by himself, or if you have a low specific number of frames, for instance, if you're working on multi-frame debugging, you can, if you're working on 5 frames, you can ask him to provide the 5 frames as separate inputs. So only do it if you have a low number of frames, because he will only select an example which you have done yourself. You have to upload each frame separately. So if it's 3 or plus 5 frames, it works. For more than that, it's, you have a lot of clicking work to do just to upload these inputs. So now for data inputs. So it can contain videos if you want. It can contain anything. It could even contain images if you really wanted to, although it's really not advised because there's a very good system for images which is already in place. So most common use cases are texts, CSV or table files, stored away in a specific format, zip archives, if you want the user to upload a lot of different things, or really anything relevant for your demo. So here, the description is very important, even more so than for other inputs, because you really need to say to the user what kind of input he should write. So if he needs a zip archive with very specific names in the zip, you need to say it, he will not guess it. If the user needs to upload a CSV file formatted with commas and not spaces and not tabs, you need to say it to him so that he knows how to process the input. Then there is the extension. So here's the extension. Like in videos, it will not be renamed, it will just be renamed, not actually converted. Which means that in your code, if you request a CSV but the user sends a zip, you will get a file named .csv, but it will still be a zip, just named as a CSV. So your code needs to check for the input type to make sure it works. So again, you don't need to do it now, but you will need to do it before the demo is fully published. And of course, we can help you through the code part as well to manage the input types. Finally, for parameters. So let me check parameters. Okay, so I will not go in details through parameters. There are a lot of different options. So checkboxes, lists, etc. It really depends on what you need. And for parameters, there's actually a very complete template with DDL. So you can follow these links and just check what you want. You can copy paste it from the DDL if you see something you like on the demo and use it. So to run the code, so the run line. So here, I've talked a bit about it yesterday. Note that a parameter in the DDL whose ID is foo can be called with $foo in addition to calling the inputs. All parameters and inputs are named as environment variables. So you can specify them here in the run, but if you need to, most of the time you won't, but if you need to, you can also get them in the code. For instance, in Python, you could use the OS library to use the getEnd and the getEnd function to know what sigma is by writing os.getEnd and the string sigma. So it's more clear if you pass all parameters through the command line, but if you have some specific use cases, you can also get it directly in the code. So finally, for the results will be saved next to the inputs, unless you specify a specific file. So you can read them directly in the demo. You've probably done it already with images or text files. You can save text as to print files and show them with as text files here. So for instance, in the template, it's done with the standard output. You can do it with other files. Now, for other things, you can have visualization as HTML. So for plotly and bokeh, you will need specific commands. You can just use the slides if you are in these specific cases. So this is what should go in your code to save correctly as HTML. And an HTML that can be read in IPOL, so that knows where to fetch the JavaScript libraries. So here it is easy in plotly and bokeh. It might be a bit different in other files, in other libraries, because ideally you need to include the library. So for instance, plotly.js needs to be included in the HTML file. So follow those lines. And if you want to use another library, then we can look together in how it can be done. In pandas, if you want to save a table, you can use the data frame to HTML method, which will display it quite nicely. And if you're using something else, you can. So here are examples of HTML results. For here, so it's a static visualization of the graph, but this one's actually interactive, and users can use their mouse to zoom or see specific values. Interactivity is nice if used sparingly, so only use it if relevant, and note that it will result in longer load times for the users, and it will make it harder to archive. There's also an option to download the file, as seen here. So if you output files in a specific format and expect the user to download it and read it with his own tools, then you can use this part. So the type is file download, and you put it in a content box. So it can be really anything you want. Here, note that out.zip is the name that is displayed here and under which it will be downloaded. Sequence.zip is the name under which it is saved by your code. So ideally, if you don't want to complicate things, use the same name in your code and in the DDL so that you can put the same name for both. Now, we arrive to the archive. Oh, we'll be right now. We arrive to the archive. So the archive is what happens when you click on archive in a demo. So for instance, I don't know if that one has it. No, it's in the print. So if you look at any demo, let's take one we know to have some archive. You just click on archive here, and you will see what is shown here, an archive of existing experiments made by other users. So of course, if you have some privacy concerns, note that when the user uploads his input, he can also select the private mode and then the archive will not be saved for his experiment, of course. So there are quite a few lines to put. So first of all, enable reconstruct, the first line. If you set it to true, the user can click here on the reconstruct button, which will recreate the experiment as if he was just running it. For this to work, you need to save all inputs and outputs, everything that is shown here in files. So in files, you write every single file you want to save in the archive. So it can be the input file, it can be the output and intermediary result file. In many cases, we recommend saving everything you display in the results. That way the reconstruct button can work. If you don't save everything, then some imaging in the reconstruct will be missing. So do not always archive everything, especially if you use heavy files. Do not archive them because it will take a lot of space, especially if you use interactive visualization. HTML files can be very heavy, especially since they include the library. In that case, it's better not to archive them. But, so it means you won't be able to reconstruct the demo, but you can archive a static image version of your visualization just for the archive, so that there is at least something. You also need to specify the parameters which were used in the demo. So in the params field, you can write their ID here. That way, when we look at the demo, we will know with which parameters the demo was run, which is very helpful if you want to know how the experiment was done. You can save here the runtime, so how long the demo took to run. And finally, the archive always part. If you set it to true, it is false by default. If you set it to true, it will archive all results. Even if they are done with example inputs that you show. It can be helpful to set it to true when you debug. If you're not debugging, but you are just publishing your demo, then set it to false. Otherwise, every time the user selects an example input, the demo will save it. So if you set it to false, which it is by default, when example images or inputs are used, they will not be saved, which is better because in 75% or more of the cases, the user will try the demo with example inputs, and you don't want to have an archive that is populated by several thousands of actually the same experiment. So the only time you need to set it to true is if you are debugging, or if your demo is not about the input, but much more about the parameters you use. So it can happen that some demos are only a few relevant inputs, but a lot of parameters, and this is what matters in this demo. In that case, it can be interesting to set it to true. But in most of the case, it is better to keep it to false. So this is all for my presentation today. Tomorrow we'll have a few more things to see. So of course I will answer a few questions today. I can answer questions tomorrow. I will show you a bit more how to troubleshoot demos. Also how to send error messages to the user. So for instance, if you want your demo to fail in a specific case, you can make it fail in a way that the users know why it failed. For instance, if the input is not right, but this is managed not by IPOL, but by your code, or if the demo does not contain, if the input does not contain something you want. So in most cases, it is done to handle failures due to the input not being what you want. So this is all for now. So we have time to answer a few questions if you have them. If not, then you already have the slides by email, so you can keep working on your demo this afternoon. I'm still here to help you. Now you have most of the details to create your demos. There are a few things I did not cover. So for inputs, for results, for instance, you can put results side by side. So for instance, if you want to show a histogram of an image or a color map of a heat map next to the image, you can do it. I can explain it to you this afternoon. It's not in the presentation because now it's very specific. Also, there are cases where you can inpaint your own image. For instance, if the user provides an image for an inpainting demo, you can ask him to create a mask directly on IPOL, saying where he would like the inpainting to happen. You can also add points to the input, so the user can make a polygon specifying a specific region, or he can select points, for instance, to say, I want you to look at these different points. For instance, for demos that require user guidance, it can be helpful. So these are very specific use cases, so they are not presented here, but of course we can help you if you are interested in those cases. So now will be the time to work on your demo, but before that, of course, time for lunch, which is at the same place as yesterday. Thank you, and people on Zoom, we'll see you tomorrow.